Hi, welcome back. So we are in Chapter 3 HCC VO1 project in the outline workflow of the project. Now in this outline, what we're going to do actually, we're going to start establishing the workflow of the project. Since we have understood the research problem, we know our standing point, it is time now to work on the technicality of the project. First of all, we said that our raw material is going to be an image. This is a very important thing to start up with. So we said that we want to reach out to the stakeholder, provide us with a data set to be already labeled. So otherwise we have to do on our own anyway, where we have normal and pneumonia images. Inside the normal folder, where it's the data set, all number of cases that we expect to have a normal X-ray chest result. And on the other one, we would have a number of images that happens to have a pneumonia X-ray chest result. This is the first thing we want to do. So in this case, I have here, which I'm going to leave for you if you would like to follow along with me, two different folders, the normal and the pneumonia cases. If I would have to open, I would see, of course, the first image for a normal chest X-ray result. Now, I have no idea how to read this image. I don't understand anything, but what I know that the stakeholders or the domain expert provided me and telling me this case is a normal case. So as the second one, and so on and so forth. And for the other pneumonia cases, if you would open the image here, it indicates that this image has a pneumonia. Now, once again, I cannot read the image, but the domain expert categorize or classify this image to have a pneumonia case. So we have both has been accomplished and all right under our control. What we're going to do from here? First of all, we have to ask a few questions. What is the actual path of the image? Is it a gray style? Is it RGB? It depends on. I think the images that we have just now seen seems to be gray scale image, so I don't have to consider them as an RGB. This is the first step. So we are dealing with a gray image. Gray means this is one channel. That's all. So we are dealing literally with a matrix, number of rows by number of columns. Now, if we want to go through the step of processing the image to make sure what kind of image we are dealing with, depends on the framework. What you are going to do with the image, what kind of a framework of AI you're going to utilize. I'm going to rely on the CNN framework, convolutional neural network, which we have dedicated long explanation on the entire framework in our third book, Prediction from the Start to the End. You might want to check that if you missed. Since we know that we're going to deal with the CNN, I'll just remind you what that looks like. I will take one image as an input. All right. In this case, we are dealing again with a gray image, one channel. The first step I would like to do with it is to expose this to a filter. And this filter might be in a square, of course, kind of a filter. It could be 3 by 3, could be 2 by 2, 4 by 4. It depends on, we have said before. And then I would do the multiplication between the image and the input. And that will outcome for me some sort of a new dimension of this image. Of course, will be reduced. Finally, I would have like this new input. I could do the exact same process one more time, expose to a new filter, right? And this time maybe smaller, could be 2 by 2 or again 3 by 3, depends. And I take the outcome of the previous layer, say this is layer 1, and I put it back again and I do the same exact thing, and I would end up again with a new image. Maybe I could do that one more time after max pooling, of course. Finally, I would get the final outcome from the third layer. M by N will be actually way smaller than the original M by N. Now, what I would do then, I'll take this outcome from the third layer and I would like to flatten that. So the M by N will be just a single array, looks like this. Now this D by 1, it will be then an input to a neural network. take this input into the first layer, which is going to be a certain neon here. And again, maybe we can put one with one more neon here. And finally, we will have an outcome only of 2 softmax to get a prediction point. Now, the outcome here would be 0 or 1, where 0 will indicate a normal, 1 will indicate pneumonia. This is the model that we want to design. By the way, for backpropagation, we will be using the standard way of backpropagation. Now, the question is, what is the best input? The first image input, which is actually originally here, I'm suggesting, for example, I would have like 720 by 1024. That's very large. The best way to do is to take this image and try to reduce it actually into a smaller dimension. Let's take it, for example, 200 by 200. Now, how to do that? Well, there are many tools that you can just resize this image to be 200 by 200. It doesn't matter then. But my suggestion here, we have to check out, you can check our material before we discuss that we don't want to lose some indication of the features inside that image. So that means that my input here, 200 by 200, it will be the main input as the original image. So how to do that? There are 2 ways of doing this. The first one, I would have come to the original folder here, and I make the process from the very beginning by changing the entire data set. Or maybe after I design my framework here, I could have just like taken a step to resize the image before we get that to be an input. Now, for our project, since we are dealing with a small scale project, are we going to do this all design on our own, or can we utilize available framework? That we can actually utilize the existing Keras library under TensorFlow instead of rewriting all this on our own, which we have done actually before in the previous book, so we could be completely independent. But why shall we reinvent the wheel if we have an available tool? Although I could tell you, you might encounter with many challenges. For example, the Python version, as we said, it turns out that TensorFlow, for example, does not work with 3.12. You have to downgrade your Python to be 3.11. Maybe there are some other compatibility issues, etc. So you might, because we are dealing with external library or we're relying on external framework. So you have to consider that if you are in a real production line. Otherwise, if there is no problem for you, you could utilize actually such a framework. And that's exactly what I'm going to do. I will be relying on this framework, TensorFlow, Keras library, and then we will design a model that actually does exactly what I have shown you here. Now, the good news, Keras over us reshape or rescale of the original image. Just all what you have to do actually to show the Keras where is the path of the 2 folders. Will recognize, well, each folder it's an independent label, and it will follow, by the way, the alphabetic order. So for example, here we have P and N letter. N happens to be in order before the P, so he will consider N is the 0 and P is the 1. If you would have some other folders with different name, it will follow the exact same orders. By sigmoid, the final output here, so you have just to make sure your folder also following a certain order that you entitled to do this. So by chance, normal happens to be 0 and pneumonia happens to be starting with letter P, which is going to be actually 1. Now, I'm not going to teach you how to actually utilize the framework of Keras or TensorFlow. I would just go through the code and assume that you understand from the documentation on your own what to do that. Now, let's go ahead and try to convert this essential design into a real code. And by the way, the question just before we close down here, where are we going to do that? What kind of machine? Well, here is many options. You need a powerful, maybe kind of a GPU machine that have a GPU capacity or a high performance CPU whatsoever. Whatever machine you have, that will be better. The higher the better, so you could have much more comfortable to even manipulate the batches or to do that much more complex. Instead of 3 layers, we can do 100. It depends on the capacity. So we're going to be relying on the collaboratory, which offer us access to some kind of a GPU, a good thing for a development purpose only, not for production capacity. So we're going to actually go to Collaboratory. In the Colab, we create a notebook and we do all this. That's exactly what we're going to do next. I will see you then.